Cool, right, last one for this week. It's a nice short one, which is exact values of trig ratios. So there's two kind of special triangles you can learn for this. Both right angled, 1, 2, root 3, 60, and 30, and 45, 1, 1, 2, 45. And what these are good for is they'll tell you the exact values of sine, cos and tan of 30, 60 and 45 degrees, and using those values we can find any other values that we want. So for example, if I wanted to do sine of 60, sine is adjacent to the hypotenuse, so you get root 3 over 2. If I wanted to do cos of 60, well, cos is the opposite. No, it's not. Adjacent over the hypotenuse, so that's going to be a half. And tan of 60, opposite over the adjacent, so opposite root 3 over 1. So tan of 60 is root 3. Do the same for 30 for this one. So we can say sine of 30, cos 30, tan 30. So sine of 30 degrees is going to be opposite over the hypotenuse, so a half. Cos 30 adjacent over the hypotenuse, so that's going to be root 3 over 2. And tan 30 is going to be opposite over the adjacent, so 1 over root 3. And lastly, we do the same again with this triangle. Sine 45, cos 45, tan 45. So sine 45 becomes 1 over root 2. Cos 45 same, 1 over root 2. And tan 45, 1 over 1. So if you can remember those triangles, you can find the exact values for some trig ratios. What we can use that for is to simplify other trig exactly based on what we know and what we've done already this week. So if I wanted to simplify sine of 135 as an exact value, what I would do is sketch sine. Find 135 degrees, there's 180, so 135 is about there. Now 135 is 45 degrees away from 180. So I know this value is going to be equivalent to 45 there. So I could say sine 135 is actually the same as sine 45. And from just now we know that sine 45 is just 1 over root 2. So we can say sine 145 is 1 over root 2 by using the equivalency of those angles. Let's try another. So if we had tan of 210 degrees, so sketch tan. So tan 210 is about there, it's 30 away from 180. So we could say this value is the same as this value, which is 30 away from 0. So that is the same as tan 30. And from just now we saw that tan of 30 was 1 over root 3. So we can say tan 210 is just 1 over root 3. Cool. Right, next bit we need is another way of finding angles. Everything we do at the moment is going to be trying to find angles based on what's equivalent. So, given cos theta is minus 3 over 5, and theta is reflex, find the exact value. Sin theta. Okay, so we're going to try a couple of these ones, and that'll be it for today. So let's write both. so we've got cos of theta, and we're trying to use that to try and find sine of theta, given that it's reflex, try and find the exact value. So first thing I do is going to be to make a right angle triangle. So cos is the adjacent over the hypotenuse. So if that's theta, the adjacent we could say is 3, and the hypotenuse we could say is 5. Just based on 3 as an adjacent, h as a hypotenuse. We can now use this to work out this other side. So we could say 5 squared equals 3 squared plus x squared. So 25 is 9 plus x squared. X squared equals 16, so x equals 4. So this side length would be 4. So if I wanted to change this into sine, I could say sine of theta, same angle, is the opposite over the hypotenuse. You get 4/5. Now, problem is, we don't know if that's positive or if it's negative, because we've got this reflex business going on. So what we're going to do is sketch a graph of sine and see if sine is positive or negative for reflex angles. So a reflex angle is an angle between 180 and 360. So those are the reflex angles, and you can see they are all negative. So sine of theta should be equal to negative 4 over 5. So you can use right angle triangles, and you can use sketches to try and find these. That's a bit too much ink in there. And sine theta would be minus 4 over 5. We try the same thing with this one. So this time we're given sine equals 2/5. So again, make a right angle triangle. There's theta. Sine is the opposite over the hypotenuse, so 2 would be the opposite, 5 would be the hypotenuse. We want to find that side. So 5 squared minus 2 squared equals x squared. 25, take 4, gives us 21. I think that's right. Yeah, so this side is going to be the square root of 21. So if I want to try and find cos of my angle, which should be alpha, is going to be my adjacent root 21 over my hypotenuse 5. All I need to do is work out whether cos is positive or negative for an obtuse angle. So if we sketch cos, so obtuse is going to be between 90 and 180. So again, cos is negative for that bit, so we need to put in a minus sign, and we get cos theta is minus root 21 over 5. So we can use sketches, and we can use right angle triangles to try and find equivalent and exact values of trig ratios. So I reckon let's try one more, maybe 2 more of these, just because it's a bit different. Cool, right, if you want to pause it and try those 2, you can. Should be pretty similar to what we've done so far. So sketch a right angle triangle, find out if it's positive or negative for obtuse and reflex, and then work out what the exact angle is. So for this one, given sine is root 3, given sine theta is root 33 over 7, so we can do 7 squared minus 33 equals x squared. So 49 minus 33 equals x squared. X squared equals 16, so x equals 4. So cos theta equals 4 over 7. We just got to find out if it's positive or negative. So it's obtuse. I have a feeling cos is always negative for obtuse. Yeah, so it's that region. So we need minus. Right, and for this one, it's a tan this time 4 over root 65. So tan is opposite over adjacent, so root 65. So you need to find the hypotenuse. So x squared equals 4 squared plus 65. So 16 plus 65, so 70, 81. So x is 9. So sine theta will be 4 over 9. And we've just got to find if it's positive or negative. So reflex for sine, again, is negative. So sine always negative there. I think every example I did was negative. But yeah, they're not always going to be negative. Do a sketch and check. Right, that's it for today. So literally 1 week left and we're done with pure maths, and then on to statistics and mechanics. Cool.